Hello, everybody, and welcome to this special training. I am so excited to be here today with Josh Goldberg. You might know him for all his work in the community with TypeScript. He's a full-time open source maintainer, has worked on things like TSConfig, if I got the name correct, and has also recently wrote a book. And I'm sure he'll tell us more about what's going on there. But we're going to be talking about advanced TypeScript today. Josh, anything specific we want to know? Anything before we get started?
Well, first off, you got the name right. Thank you. I appreciate that. Yeah, I'm happy to chat. This is going to be for folks who already understand the foundations of TypeScript. So I'm not going to review what is a type or other like the difference between JavaScript and TypeScript level topics. But please do let me know if anything I say is unclear. I'm intentionally leaving it open, and we're just going to play around the TypeScript playground for a while. So let me know how I can make this great for you.
Fantastic. Well, Josh, take it away. Where are we starting today?
We're going to start with a screen share, which we previously confirmed does in fact work. And we're going to start at the TypeScript playground. So just confirming, I'm sharing the screen okay. Everything's going well so far.
Looks
Awesome.
fantastic.
Now, when you start using TypeScript, you'll probably start writing things like function, I don't know, like get text length that takes in text string and returns text.length. That just as an example. You might
Josh,
have
one
already.
request. Can you bump one more time?
Ooh, yes. Thank you. Good question. Good request.
Thanks.
Cool. And if you're new to TypeScript, you might start doing things like, oh, I don't know what this is supposed to be. I'm going to use any. But as we all know, the any type is a no-no unless it's absolutely necessary or you don't really have the time to find the right one. Sometimes it's useful. Most of the times it's not correct. You might know that you could write the explicit return type here. Some people prefer explicit types. For return types of functions, sometimes they're useful. Oftentimes you don't need to. That's kind of like the foundation level stuff. But once you start getting really fancy, schmancy, advanced in the type system, once you start modeling more complex data, you'll eventually discover that the type system is its own language. That if you wanted to like write some kind of like meta programming stuff in the type system, it actually supports that. It's what we call Turing complete. So what I want to just as an example go through today is something like Zod, where if we go to zod.dev and just get like a quick introduction, a little code snippet. My God, they have so many sponsors. And you get to Zod. Here we go. Fun fact, the TypeScript Playground actually supports importing types from packages. So we can see here that if you hover over Zod works. And the way Zod really likes you to do things is by creating a schema, Zod.object, where like, I don't know, like name is a string and age is z.number. All hail Zod indeed, General Zod. For those who aren't familiar, the word Zod comes from the Superman villain, General Zod, a Kryptonian general. Love a cutely themed package. So my schema, Zod actually does some really interesting things. If you say type my schema equals z.infer, is it lowercase now? Type of my schema. And then there's this cute little playground feature, these little 2/ comments. You'll see that in the line here, TypeScript just shows us as a nice little editor utility, the type just above the comment. It's age number name string. And that's fascinating to me. That's so cool that TypeScript is able to take in this object description and then turn that into a type system thing. So freaking cool. And yeah, this does work in VS Code. You do need an extension. VS Code, oh God, 2/ queries. It's made from our old friend Orta, who used to be on the TypeScript team. So I'm just going to go ahead and put this in the Zoom chat. If you look up VS Code 2/, you'll get it. I like that. I'm glad you're excited about that too.
I, I'm
Glad.
not kidding. I was doing something the other day and I literally had to figure out how to do this without this. Now that I know this, I'm mad at myself for the amount of time I spent on it. So thank you for showing us. I think I speak for everybody on this call right now.
My pleasure. I'm just happy to have broken my personal record of how long it took to get a mind blown. Under a minute. Okay, so I want to do this. I want to show off how to do something like this. And I'm actually really excited about this particular example of type system shenanigans because the type system is super powerful and it's really fun to play around with it. You can do all sorts of wacky things, but it's important to recognize that the type system being fun is not an excuse to use it in your production quality code that your teammates will hate you if you start doing wacky shenanigans unless there's an actual justification for them, if they're worth the type complexity. So I want to be very clear here. What we're going to show is like conditional types and features like infer and const in the type system. And they are worth it in many cases. But the cost is people have to learn this stuff. And this stuff is not commonly understood by a lot of developers. So, caveats. Sound good so far? Awesome. So I'm gonna start here. I have you can't see, but I have my own notes offline. So if I start jerking my head around, it's because the TypeScript playground over there is giving me issues. Let's say that you wanted to make your own Zod. Let's say you wanted to make like a function Z number. I'm just going to use flat functions, not namespace stuff here. If you wanted to, I'm not going to show the implementation because we're just working in the type system. I'm going to say Z number creates schema number. And the way you might represent that in your data shape is type number. You might have like I don't know, like value. We don't really need that. You might do like a type number, or let's call it primitive number, because TypeScript actually has a really important naming thing here. They're primitives like number and string. So let's go ahead and make a string schema string. And then there are also literals like quote ABC or 1, the number. And those aren't the same thing. If you've played around with union types, you might have done something before like type exit code equals 0 or -1 or 1 or 2 or something like that. That's not the same as number. And that difference will show up soon. Because if you look at type any known schema equals schema number or schema string, just as an example, we'll see that it's, or pardon me, we'll see that it's schema number or schema string. And if we put like schema primitive equals any known schema primitive, look at this. Thank you, TypeScript autocomplete. Also going to use my little 2/friend here. We see it's the union of string or number. It's not any old string. It's specifically one of those two literals, either quote string or quote number. I'm going to pause. Any questions or comments so far? If there's absolute silence, that's okay. Also, that makes sense to me. Comments are helpful. Thank you.
Yeah, this makes sense. The question, and you're probably going to go there, is maybe why would you want to do it? But I know this is also an abstracted example.
Yes. There are actually two new things I just introduced here. One is the concept that we have these literal types. And the other is that actually I showed this syntax here to taking a type and then grabbing some property by name. You can't do dot primitive in the type system. You have to do this array thingy. We'll use that later. And yes, thank you, Rob. Good question. I could have named this type if I wanted to. I could have named this Rob Ocel. The name, it would be really, really awkward if I went the whole workshop calling it Rob Ocel. Also, by the way, look at this awesome refactoring here. TypeScript also changed the literal in that. That's not necessary for the workshop. I just thought that was a cute little feature they have. But cool. What I want to do is I want to infer. I want to create logic in the type system. I'm actually going to, oh, TypeScript tooling is so nice. I'm going to put these over here. I want to say type infer, and then it's going to take in a schema. This is resisting the urge here. Type in schema, and well, what am I going to do here? If I were to write this in JavaScript, I would say schema. Well, that schema is either a schema number or a schema string. I might say if schema dot primitive equals string, return, I don't know, string, just as an example, else return schema dot, well, else return number. Now, you might be saying here, Josh, you silly goose, that you could just return schema dot primitive, but I promise it'll get more complicated. The point is, what I'm actually doing really is a ternary here. Let's call it a string or some number, just to make it different. This is how the JavaScript might look. But what we want is the equivalent of this logic in the type system. Now, JavaScript I see the syntax highlighting is, so let's call it zinfer. JavaScript functions take in runtime parameters. Now, fun fact, actually, parameter is what you declare, like schema. Argument is what you give. And I remember this terminology difference as you can give someone an argument. That's a common phrase, but you don't give someone a parameter. That's not a phrase. That difference only really becomes important when you start deeply working on TypeScript or other language tooling. But I digress. We want to be able to create the equivalent of thing that takes in a parameter and then returns something based on that parameter. And in the type system land, that's what we use generics for. We might declare a generic type schema. And actually, in the type system, you can use ternaries. That's how you add logic. You can say, does the schema extend schema number? Pardon me, extends. If the schema does extend schema number, meaning is this an example of a schema number, then the result of the infer type, the return, is a string. Otherwise, it's some number. So if we do like type my infer equals infer of, I don't know, let's say primitive number, then I would like to have y'all guess in the chat what when I type in the question mark is TypeScript going to say this type is for my infer? Shout it out or say in the chat. Some number. Yes, exactly. Thank you, Dustin. And everyone else who was furiously typing away and almost got it in on time, I'm sure. Oh no. Actually, I'm sorry. I typoed. You were correct in that what I was trying to do, and I messed up and there was a bug. It was an accidental trick question. I'm so sorry. That was not intentional. That's bad workshop leading on my end. Now we're correct.
I feel had.
Yeah. My bad. See, you can tell this is actually live coding and not pre-recorded because I'm messing up. I would never mess up intentionally. That would be genius. The schema is, well, it's not a string, so we give some number. And if we were to switch this to primitive string, it would be a schema string, so we return a string. Yeah, I'm really doing great here. So just to bring this back a little bit to more like our Zod example, I'm going to say my schema equals, I don't know, z string, and then I'm going to swap out the object literal here with the fun type of operator or keyword. Yeah, in the type system, which is only coincidentally named the same as the runtime type of operator. The fact that I have to explain that and it's confusing is a constant irritant in learning TypeScript. But here it's the same thing where type of my schema is, well, you can't hover over it. So I'm going to say type of my schema equals. Actually, you know what I'm going to do? I'm going to use a little TypeScript tool here. I'm going to select this, see if it gives me the option to refactor. It doesn't. Oh, well. There we go. All right. So that's cool. And I'll pause there. Any questions or comments so far? So far, so good. Awesome. We might run a little early on finishing the main section of the workshop, in which case, great, we'll just have time to chat and answer questions. But what I want to do is I want to build towards the Z object thing. And the Z object thing is actually a little tricky. Because, well, in order to do an object, we're going to have to find some way to loop through the properties, to map the properties. All the keys become equivalent keys, all the values become some other value. So that's going to be the end goal. But before then, I want to note that Zod has another cool feature here that I'm going to try to emulate in the type system. Zod also has literals. Declare function z literal t extend. Let's call it let's just say value. And I'm going to say that it takes in the value of that type. And then let's call it a let's schema literal of value, because we've introduced generics. And fun fact, you can have them, have them on functions too. So schema literal, let's call it generic type parameter value and value. So you might do something like, say, const my schema equals the literal ABC. And then this would be type schema literal of string. Well, that's not quite what we wanted, is it? I wanted it to be a literal, not the primitive, the literal. There's a difference. But the problem is when you pass an argument to TypeScript with a generic function, pass an argument to a generic function as one of its generic parameters, TypeScript needs to know what you meant. Did you mean the primitive or the literal if it's a string? And most of the time in real world code, the TypeScript team and many folks have found that people generally just want the string. They don't want the literal. They don't that's not often useful, which is why if you hover over the literal, you'll see that TypeScript has inferred the type argument to be string for value. So there's actually a really nice hint in the type system they added pretty recently you can use for this called const, only coincidentally named the same as the variable, where const says, instead of inferring the most common, generally useful type for this, give me the most read-only, immutable, specific type possible. As we can see as I cut and paste, cut and paste, it switches the inference from schema literal string to schema literal ABC, because it switches it from the general type arguments to the more specific literal version of it. And I'll pause there. Does that make sense and sound reasonable to everyone? Yeah.
I know some of us have proceeded to just letting the waves lap over us at this point, but I don't know that I specifically have a question for that group.
That's good to know. Thanks. I'm going to start slowing down because this is starting to get more and more nitty gritty in the type system. I will also note that because this is a different way of thinking about code, I find that it's normally easiest, or it's normally most successful to onboard to it in like 2 or 3 tries of different types. Or like attending a workshop and then reading a deep dive, or like doing a workshop and then, diving into code. Like it takes a couple times often.
This might be a little helpful for those of us that have had the wave go over us a little bit. I think the code itself makes sense. I think for many of us, we're like, I see how you got there. We're following. But what are the maybe real world use cases in which I would want to apply this, and maybe applying this to a real world situation might help bridge some gaps in our minds?
That's a great question. Thank you. What are the real world uses for this? Let's try that out. I'm going to make a new playground here. I'm going to say function z literal returns value. Function validate literal schema. So we might have a value, unknown, and then a schema literal value of unknown. Let's say we have a generic for this function, return value equals schema dot value. So if value is not equal to throw new error, incorrect value. Actually, let's make this a template literal string. This is an example of a validation for the literal schema. You might write equivalent ones for the number, the string, later we'll see object and so on. The reason why I bring up Zod, and I now realize did not explain this, thank you for asking, is that it's really common in code to want to use something like Zod to validate your data and say throw an error or return something unhappy if the data doesn't actually match what you wanted. So like going back to something more valid or real world, validate data. Data might be unknown. So const is valid equals my schema dot safe parse data. If is valid, then let's look at the data. Oh, it doesn't work. Ha ha. Well, that's unfortunate. Oh, const results. What type is results? Sorry, I always forget how different validation libraries do things. There we go. So you might want to be able to, let's say, declare a schema, say my schema, and then do something like a parse or validate on some data that's unknown. Let's say like you might validate data fs read file sync data.json. Please forgive me for using not the async version of this. The only way to get that this result is the correct type, age, number, name string, is to make sure that the type system understands my schema is this fancy schmancy type. It's even fancier if we hover over, where it's got age, number, name string. Does that answer the question you're looking for?
I think maybe part of it would be I think the way I'm thinking about it is I would normally just use Zod to do all this, and you're going straight for TypeScript. So this is kind of showing how Zod works under the hood, and like if we wanted to, instead of pulling in Zod and all of its magic, we wanted to write our own validators and schemas, this would be the approach.
Yes.
Great. I'm there now. I can't speak for others.
Cool. Thank you. I apologize for going so deep so fast. I'm still learning how to teach and explain this stuff.
Your explanations are wonderful.
Cool. I'm going to pause, recap what we've seen so far, pause, and then continue. So first pause. Any other questions or comments so far?
I'm going to ask one qualifier. So if you did the caret question after validate data, would it say maybe not on result, but on the on the result of it. Okay, so it gives you the any type because it doesn't actually have a return. Got it.
Mm-hmm. But we could return results. And now it's, well, you can't see it, but it's returning age, number, name string.
Right. Okay. So this would be a quick way to be like, hey, I don't know what this user input is, but I'm going to validate that it is, and you can assume it will or will not be that after this. And if it's not,
Yeah.
I've got an error I can catch.
Yeah. Actually, there's another really nice, in addition to that, so yes to that, not saying no. In addition to that is env schema. If you want to validate that your process.env is good and happy, you might do like first input z.string other thing z.string.optional, let's say. We're not going to cover optional in this workshop, just showing an example. You might do like const envs equals validate my or env schema.parse process.env. And then Zod will throw an error. There's a return instead of throw version 2. Zod will throw an error if your process.env doesn't have this stuff. So actually, you could just do process.env.first input after this, but the types haven't been hooked up to let TypeScript know that it's a string. So this is actually a really common use case for Zod that a lot of people have to write themselves because they don't know of it.
That's neat. And is in would you have to do more to connect M schema? Sorry, is env schema a system const? I see you declared it in line, but is there another step you would have to do to hook it into the process env, or is this just special notation?
This is just, it's all coincidental notation here, other than the fact that Zod calls this thing Z and has those named methods. So you can name this, do with it whatever you want. I'm not sure I follow the question, sorry.
You answered it correctly. I got
Awesome.
it. Yeah, it's because of the parse. I'm jumping through a different mental hoop.
Cool. And for those who might be thinking, why the hell do we want this? Let's say my favorite string method to uppercase, let's say you wanted to do that. This is okay because we validated that it exists. But if you were to do this before the whole Z shenanigans, well, TypeScript doesn't know that it definitely exists. So we get this unfortunate error here. Good luck, Dustin. I believe in you. Okay. Cool. Continuing the first pause before we recap, pause, and then move on. Any other questions or comments in the chat or out loud?
I don't want to let you be all by yourself. No questions so far. I think this is going to be useful by many people, the environment.
Awesome.
Nothing seems in chat.
Cool. Well, thanks for letting me know. In that case, I'm going to recap. Dustin's back. The stuff we went over so far is, well, first, this is Zod, an example of one of the schema validation libraries out there. There are a few others like Yup and Archetype, but Zod is quite popular, so I use it. Zod allows you to create a schema, for example, .object or .number. Object will take in properties, and then validate a schema. And what's really cool here is that you can do like type my schema equals z.infer type of my schema, where it can actually infer from the types. And that infer from the types, that generating that result type, is what you need to use, what this workshop is calling advanced TypeScript to use. I would call it fun TypeScript or shenanigans. So what we've gone over so far is we've just started to build up type system representations of our data types. So like interface schema number, which indicates it's a number, schema string is a string. And then we also have literals, because Zod allows you to ensure that something is, let's say, a literal. So like that's a generic type, schema literal of value. And then we didn't get to using the literals yet, but we did add inference for the number and string schemas, which is the first, I think, really wacky or unusual thing in the type system. Logic. Most other languages that have type systems don't have logic in the type system like this. But it's a ternary. It's a generic type infer where you can pass in a, let's see, well, I did this somewhere in code. Oops. You can pass in, let's say, like my schema equals infer, here we go. Sorry, I lost my code. Infer, let's say, const my numbers or my schema equals z schema, z string, and then infer type of my schema. And because we know that my schema, because we know my schema is schema string, my schema is known to be a string because we passed in, let's make a type my schema type equals type of my schema, and then use that there. I'm just refactoring so I can get a nice little comment here. Because we know that this is a schema string, we've passed schema string into infer. That's the argument for the schema type parameter. We then check, does our schema type parameter extend from schema string, which is true in this case because schema string is schema string. And that means the result of the ternary is the true case, a string, rather than the false, some number. So that's what we've covered so far, and I'm about to extend that to literals. Any questions or comments before we continue? Cool. So we've got this infer type. I'm going to move it down below the literals. And we've got, let's see, my schema. I'm going to delete the old one. And let's say we've got my schema is the literal ABC, which, oh, I forgot to mention the recap. Const tells TypeScript to use the literal, most precise version of the type rather than, let's kind of guess that it's a primitive, the string. So what we want to do now is in our logic, we want to add to the ternary. We want to say if the schema extends schema literal, I'm going to use an any here for now, say it's some literal. Otherwise, we go back to the previous logic of, well, if it's a string, it's a string. Otherwise, remember, I'm going to say my literal just to make it clear. And it works. It's the same idea as before. We're using a ternary in the type system. Just now it's a kind of ugly nested ternary where we're passing in my schema type, which is a schema literal of something. And then we check, is the schema we're providing, in this case, my schema type, an example of, or is it assignable to, schema literal of anything? If so, which is true here, we use my literal. Now, before we dive into fixing this any to be something more precise and accurate, or just precise, I guess, any questions or comments on this?
Syntax question. Is there any way
Mhm.
to do it without ternaries?
No, and it's so ugly. I really wish there was.
I'm thinking of all the threads. Usually it's Tanner like showing something he wrote for TanStack, and it's like, man, that I understand why this is that way, but I really wish it wasn't a ternary. Can you do something else?
Yeah. The type
Okay.
system is new and different and therefore confusing and obscure to many enough as it is. And then the fact that all the logic is ternaries doesn't exactly help with that, I think.
Fair.
Ooh,
I
interesting
think Jamie's
question
asking
from
the same
Jamie.
question I have, but from a different perspective.
Yeah, I just want to confirm, Jamie. Are you asking, like, could we do the function version of this, but in the type system, or some way of telling TypeScript this without such an ugly syntax? If that's the question, then the answer, unfortunately, is again, nope. Sorry. I will say, though,
We can
there
dream.
we can dream. There is, I think, once you really get used to it, if you do this enough, there is a kind of beauty in the fact that there's only one way of doing things. One gets used to it. It's actually not so bad once you're used to it. But it's the getting used to it that does for many, myself included, take a little while. I hope by the end of the workshop, we'll all appreciate the beauty. Yeah, actually, that's a great point. I learned to code in college in C++ after Java in high school. And my God, C++ template macros and whatnot are a god-awful way of doing things. So yeah, maybe this is the best approach. Perhaps the TypeScript team, after a decade of TypeScript, is correct in their belief that it's preferable to just have this syntax and none other. But cool. Let's move on. Because I don't want it to be just any old literal. I want it to be specifically the thing we're passing in. Let's call it ABC. What I want to do is I want to be able to say not just any, but if it extends a schema literal of some inferred literal for the value, that's this value here instead of any, use that value. If you could infer what that value is, if you could do something like, I don't know, infer value and then have it be my value or the value there, wouldn't that be nice? And that's exactly how that works. There's an infer keyword in the type system. Infer says, if this can be true, then you can now use that. We have pulled that out for you in the true case of the type system ternary. We're saying it extends schema literal with some value type argument or parameter. And if you can infer that, then that's now useful to you. So you can use it. And look at this, ABC down there. Pausing for questions. Indeed. Honestly, I think this is a really beautiful syntax. With the constraint that you have to use ternaries for your conditional types, this is, I think, really a nifty way to do things. Any questions or comments?
And the reason on 39 you don't have to do infer value as const or something like that is because we're using the schema literal const on 36. Yeah.
Exactly. That feels good to hear. Exactly. We're defining how the thing works here. And then later on, we're just checking if the thing was set up for us in whatever way it was declared. That's exactly right. Agree to disagree, Simone.
I I think to Simone's point a
Simone, pardon me.
little bit, uh mental model maybe for a second. Like how would you you're looking at this for the first time. You're jumping into somebody's code base probably. You're seeing like this infer value. How would how would you go about backtracing to understand the const? Like, we're fortunate in that you put the two lines that are relevant here, four
Yeah.
lines apart, and we can see it very clearly in front of us. But in a bigger code base type system, like, what's maybe a good debugging or um, backtracking technique to understand that that's the behavior we're seeing and observing?
That's a great question. I really appreciate you asking that. Um, I don't have one specific, like, arrow, bullseye, golden ticket here, but there are a couple of good strategies that I think are really useful. And they revolve around go to definition and find all references. So if you right click go to definition, you can see where the thing is declared. Scroll me up a little more than I wanted, but I went from, it ended up being line 39 to 32. So first I would go to definition to see what is the stuff that I'm using. In this case, I can see it's actually a fairly straightforward interface where there's nothing around const, but there's saying that, okay, my data storage in the type system, the shape of my values is this interface. That's step one. So I know it's not here because there's no const here. The next would be to find all references on schema literal. Oh, that doesn't exist in the playground, does it? Well, you can command click on Mac, I think control click on Windows to simulate find all references, or in this case, you can just text search because it's the one file. But either way, I would see that schema literal. I want to find out where it's being declared for us or who's declaring it. Which means if I were to find all references and find the z literal function, I might see that the way one declares a schema literal is by passing in some value type parameter that's given. In this case, we can see from the z literal function, and that's where the const comes from. So similar to how you might trace through, like logs in performance or a stack trace, or just in regular code, find all references, go to definition and such. I would suggest using those same strategies in the type system, specifically seeing the trail of where the thing is declared and then how you got to that from the usage of it. Does that answer your question?
It does. And that makes a lot of sense. It's one of those things I think practice makes perfect, to be perfectly honest. It's like, I probably won't get that. I'll follow those steps. I'll get there and then I'll go watch this again, do it again, and then it'll probably click after the third time.
Makes sense. When I first learned to code, I had a real hard time with functions and I just had to keep doing them over and over. And I think that there's a similar like conceptual gap between, seeing codes in series versus jumping around that you get here.
Mm-hmm.
Any other questions or comments before we continue past infers before I recap? Alrighty, let's recap and then continue. So to recap, we just added a new case in our infer. So it's a 2-level ternary now. We're saying if the schema is some schema literal with some inferred value type parameter or type argument, then we grab out the value of that value, the type argument there. For example, if we say z literal abc, where because we used const value, it is in fact always const, then we can grab the type of that, which is schema literal, and pass it to infer, which says, okay, your schema does extend schema literal. The infer value is ABC. Your result is ABC. Boom. Great. There are 2 more features in Zod I want to recreate. Unions and objects. Unions are ORs in the type system. To recap, by union, I do mean what TypeScript calls a union. I mean type string-ish equals string or undefined. Or like, you might say like ID-ish equals string or number, let's say. In the type system, it's something that could be one of 2 possible things at once, string or number. And Zod and similar schema validation libraries do allow you to do that. For example, you might do, well, let's just start writing that function there. You might do, I don't know, equals z union of either apple or banana, say. Let's say that everyone has a favorite fruit and it's either apple or banana. That's a real world use case that we can all relate to, right? Let's use functions, z union. We might do, constant value where, oops, wrong things. Values is an array of value. And you get a schema union of value. Or actually, schema union looks, I'm going to say, pretty similar to schema literal. Value is value. Now, there are a couple ways you could do this. I'm actually going to use a new system or type system feature for this one. We don't have too many more of those to go through, don't worry. Where I'm going to say, I want to, in my type system, recognize that this is an array. I'm going to say that it's some array is the values. And yes, I'm using any. Sometimes it's okay to use any. Where here I'm saying, I I'm going to give myself this values type parameter for the type of my values. And specifically, it must extend from or be some kind of array. This is kind of like adding a type annotation to your function in normal TypeScript land, in runtime land. We're saying you can pass something here, pass whatever you want, as long as it's an array of something. And I'll pause there. Any questions or comments?
I'm gonna ask two. 45. You did use an array. Is there a reason you wouldn't use the pipe? I don't know what to call it, but I'm gonna call it the pipe. Is there a reason you wouldn't use a pipe to join apple and banana versus using an array here?
Great question, because this is runtime. We're inferring our types from the runtime values. And this is a runtime. Now you could explicitly say in your types, I haven't showed this or used it yet, but you could explicitly say it's apple or banana array, something like that. By the way, this syntax is, oh, whoops, very ugly. I also forgot my parentheses and spacing. Whoops. You can do that, where it's an array of apple or banana. You could explicitly say that. In fact, you could have actually said explicitly like my schema arrays or a generic syntax of ABC before instead of this const thing. But this is a lot of squiggly lines, so I'm trying to avoid using that.
Totally. And then the second question is thing brackets or array arrows thing.
Option. Actually, I'm going to make a new TypeScript playground for this. Const option 1, or I'm going to call this, what is it? Option primitive is string array. And then const option generic array of string equals. Is this what you're asking?
I am asking why one or over the other. Yeah.
Yeah, great question. It's purely pedagogical. A phrase meaning they actually have no functional difference. TypeScript treats them the same. It's just your personal stylistic choice. In fact, one of the, as you mentioned, the things I work on, TypeScript ESLint, or the linter, standard linter thing for TypeScript or ESLint plugin, we actually have an array type rule. By default, we use the what we call simple. I don't like that word, but simple form, which is this one, this string array. But you can configure it to enforce the generic form, this one. There you go, this one. By far the most important thing, probably the only really important thing, is being consistent. If someone has to read your code base and swap between the two constantly, it's a pain in the butt and it's confusing. Why did they use one or the other?
I agree with that.
There are some small reasons one or the other, but does that sound reasonable?
That seems reasonable. I think part of the reason I personally lean over to the array, the generic syntax, as we're going to call it, because of the read-only permutations of it. But I see why you can get away with only doing it as the primitive type.
Yeah. Honestly, that is a good point. That is a point in favor of the generic one, that like there is already read-only array and these things. And honestly, all the other generics, like class and set are this syntax. Why not arrays?
Mm-hmm.
The point, I'm not saying which point is weighted higher, but a point in the opposite direction is that in TypeScript land, TypeScript represents how JavaScript understands the difference between like let value 1 number, value 1 lowercase number, value 2. Like there is a difference between these two things. And when you use arrays syntax like this, it's actually aligns to the better, the real one, the primitive one. Whereas this like class-based thing is like this weird thing. You can use new number, but it's not recommended. It's like this weird thing in the language no one likes.
Mm-hmm.
So pedagogically, like in terms of teaching TypeScript, I find this to be a little smoother. Like people just, okay, I don't have to teach you generic syntax, but you're right that both have advantages, and that is the generic one is more in line with like map and set and others. We don't. Great question. You look like you're about to ask something else.
I'm gonna ask anybody else have any questions. I've been hogging the mic. We're good for now.
Cool.
Yes.
All right, so just to recap, we're talking about unions here, where we passed in some kind of array. So it's like a type annotation, some kind of array for our values to Z union. And as a result, our schema is a schema of the array. This is actually, by the way, a type of array called tuple. It's a fixed size array. The union is apple, banana. So I'm actually gonna try this now in the infer, see what happens. I'm gonna add yet another case. Schema extends schema union infer values. If so, it's values. Otherwise, it's all the other stuff we tried before. And let's see if this works. Look at that. So, it kind of works. It actually gives us the tuple of apple banana. It's basically acting the same thing as our Z literal from before. But it's giving us this fixed size array. What I want it to be was what you described as the or. That's what I call it too, the apple or banana. So that's kind of unfortunate. I actually have to refer to my notes to remember how to solve this particular one. I'm just gonna paste this code here and then explain it. Let's see. Unwrap of values. Oh no. Here we go. Where's my, there we go, extends any. So I'm gonna, oh dear, I've confused myself and lost track of where I was. My apologies.
I think you were on the second tab.
Was I on the second tab? Oh.
Nope, I'm wrong. Ignore me.
I'm just gonna get a working one here. Let's see what the difference was. So Z union of, so this is the same. Values extends any. I'm adding the same constraint on the interface because I then wrote this unwrap type that takes in our values and checks. Does values extend from an array of some inferred value? If so, we infer on the value. So now let's see what happens if we don't do recursive types. Aha. Oh my God, that's what the problem was. I forgot to put Z literal. Okay, so my schema is a union schema of not the literal apple and banana, but of a literal schema of apple or a literal schema of banana. I'm sorry, that was a mess up on my end. Here we go. So it's a union schema of literally the apple or the literal schema of the banana. So now if we look at the my schema, by the way, I'm just going to go ahead and plop the link to the playground in the chat. That's a giant blue blob if you want to follow along at home with it. Here, let's hide that unwrap thing for now. Here we go. So now our Z union still returns a union schema, and our Z union is unwrapped in a sense where we're checking, does the schema extend it? If so, we return that values, which is an array of the two literal schemas. So what I want to be able to do is I want to take that array of the literal schemas and turn it into apple or banana, like this thing or that thing. And the way I might do that is with this unwrap type, where we're again using this infer thingy, where we're checking, does values extend from an array of some values or some value? If so, we get value. And that works because it is an array containing apple schema or banana schema, which means we get back that beautiful union type of apple schema or banana schema. I'm going to pause because I don't think I explained that very well and check. Does that kind of make sense? Any clarifying questions?
Let me try to regurgitate. The unwrap utility allows you to take an array type and unfurl it into its typed union, so to speak.
Mm-hmm. Yes. So like get elements of array type would be another name for it, which I'm going to go with for now.
Okay. That makes sense. Oh. Well, actually, now that actually is a question. I thought unwrap was actually a TypeScript utility.
Oh, sorry.
Yeah, no, I'm with you now. So I guess how did you which part of this is now unraveling it? I guess I think I lost you there.
Sure. I'll answer you, and then I'll answer the great question from Mattia in the chat. Can I actually explain what I did wrong and why I was wrong? That's a great question. So what's happening now is let's I'm gonna extract this again. My schema type type my schema type equals type of, just so I can get the let me scroll down the page just a little bit. Oh, look at how much better that is. Okay. So my schema type is a union schema that contains two things in the array: the literal schema of apple and the literal schema of banana. That's a tuple type where the first element is that, second element is that. You can think of it as an array of a union type where the union type is literal apple or literal banana. So we're passing this in. This is what we're passing in to infer. And I actually, when I copy and pasted, flip the order. It doesn't matter. It's not a schema number, not a schema string, not a literal schema. It is a union schema with some infer values, which is that big old fancy type we got, which means we're now passing this big old fancy type into get elements of array type, which checks, is the values some array of something, which it is. In which case we extract that out. We're inferring the value and return that. Otherwise, we return never, which is like the false never used case in the type system.
Okay. No,
Never
I'm following.
is totally invalid, should never be hit. That's another way of saying the never type. It's just like a nice keyword to indicate that we don't like this, don't use it. Make sense?
That makes a lot of sense now.
Cool. Well, what I was doing wrong before is I forgot this. I forgot to wrap these in literal schema. So then we were getting, oh well, we were passing the wrong thing into infer schema, and this actually works now where the schema does infer apple or banana. But you might this isn't right for the way Zod does things. Like you might want to do a Z union of like an object type, or a Z union of literal or some object type or something. So
saying this way also maybe a valid thing to say. So Z literal apple is the equivalent of writing string apple as const. It maybe not exactly one and the same, but they're similar.
In the way that this is stored in our type shapes is this. And then the result will be like apple as const.
Got it.
Is that what you're looking for?
I trying to explain. I think I was trying to relate those two concepts because that might be a missing piece for comprehension.
Got it. In that case,
Mattia,
yes.
we get you covered. That's the better question. Mattia, did you understand?
Yay.
Woohoo!
Thank you for asking.
I think, as always, we're always just balancing on this line between, are you showing us something that's TypeScript core, or are you showing us something that is the fun things we're doing to imitate Zod?
Yeah.
So there's always that back and forth between what part of this is universal and what part of this is germane to the example. I think that's where he was coming from.
I appreciate you going in that direction. That's a good direction to go in. Another reason why I really like the Zod example, in addition to just things like schema validation, Zod style being really useful, is that these are all core concepts in the type system that if you want to do advanced shenanigans with it, are relevant and useful. Most shenanigans, the way like Zod is a shenanigan, use most or all of these things. So like if you were to re-implement Lodash or underscore, something like that, each of those functions in there, some of them are simpler, some of them use some of this. All of the Lodash types use all of these features and more. I don't know if that actually answers your question, but I do promise that this is a lot of like foundationally useful stuff in the type system. Or shenanigans. Which is not a good term for me to use. I would say more complex types would be a better term.
Do you find that this code is these kinds of things that you're showing us here, especially because it really seems like it has a lot of strong, well, we're building it to do things with validation, but Do you think that this kind of would occur reasonably in application code? Do you think that this is, some people have always said like, oh, the hairiest parts of TypeScript show up only in library code if you're a library author. But I could see situations where this is coming up organically in maybe backend code, especially with the data access layers. Like, I don't know. What are your thoughts on how common or how surprised you would be if this showed up in application code versus like in the code for Zod, for example?
It's a great question. And I love that split. It's what I was planning on bringing up when you started asking the question until you brought it up yourself. Application code versus library code. There are a few delineations one might draw along that line. Like there's your code versus the NPM or whatever packages you're taking in. Or like your core logic versus the little utility functions you wrote versus NPM. I'd say you're absolutely right. The more this stuff, these complex things you use in application code, the worse. You want your application code to be simple, readable, straightforward. As you start doing these things, that's when you generally are realizing, oh, I'm building a framework, or oh, I'm building general use utilities. It's very rare that you really want to use a lot of this stuff in application code. So I guess another name for this workshop could have been like library level TypeScript or utility style TypeScript or something like that. Does that answer what you were looking for?
Yeah. Yeah. Yep.
It's sad, we build all these beautiful, cool things from this point of view in the type system for TypeScript. And then we explicitly tell people, you probably shouldn't be using this. Such is life. With any programming language, I think the more fun features are the things that you really want to restrict to certain generic areas of the code base.
Well, it's nice because they're there when you need them.
Yeah.
I mean, you have to have the tools, or else you just have an area of the problem space for which you cannot express a solution.
Yeah. I also like what Jamie brings up in the chat. We still do benefit from it, at least even if it's behind the curtains. Yeah. I've yet to find a large project where I haven't had to eventually pull back the curtains and debug, why is this schema validation error happening, or some stuff like that. And then if you do that in TypeScript, well, eventually you're going to see something like this. And let's hope you attended the workshop on July 17th. Cool. Any other questions or comments before we move on from unions into the last thing, the objects? Cool. Okay, objects. Oh boy. What am I going to do here? So what we want to do is we want to be able to, I'm just going to get rid of some comments. Boop. We want to be able to take, I don't know, like some kind of const my schema equals z object, where we can pass in an object saying like age is z number. It'll never stop being funny to me to call things a number, or age a number. Oh, I just realized I've been using lowercase for those. Let's switch that to uppercase. Age is a number, and then happy is, let's say it's z literal, called this lowercase, z literal of or let's say z union of z literal false, z literal true. I forgot a starting thing there. Okay, now this is Boolean. Boolean is a union of false or true, but I would just like to use this as an example in the type system. Actually, you know what? Let's say this favorite fruit. So fun fact on that one. Favorite fruit is either apple or banana. I want to be able to do this. So I'm going to have to write my function, declare function z object, which takes in a const values, let's say, values, and returns an object schema of values. I'm again omitting the implementation because it doesn't really matter here. It could just be returning an object that satisfies this shape. Values, where, I don't know, values. Okay. So if I look at my schema, I'm going to have to put it on a new line to get the right positioning of this little 2/ comment. We get an object schema with an age, which is a schema number, and a favorite fruit, which is a union of schema apple or schema banana. Make sense and sound reasonable so far? Any questions on this? This is pretty similar to what we've been doing so far. So if you're lost and underneath the waves now, well, I hope this doesn't push you further underneath the waves. Schema extends object schema of some infer values. Actually, let me just make sure. Did I use anything else with values? I did. I used union schema. So let's call this is an object schema. True, just to make sure that we don't get confused between objects and unions. So, I'm gonna just get turn object schema into object. I'm gonna start writing this type. I'm just gonna say, I'll put it above the infer. Values equals values. Okay. So now my result, if I can uncomment and fit this all on one monitor area. Scroll down just a little bit. Okay, so my schema is, well, we got that it's an object, but it really should have been age is a number, and favorite fruit is that union of apple or banana, not union schema of array containing literals, blah, blah, blah. So we're part of the way there. We've gotten that it's an object. We could correctly detect it's an object schema, but we need to recurse. We need to do what's called a map in the type system land, kind of like an array map, not like Map Explorer or like before GPS is how you got from New York to Florida. I mean map like take a set of values and turn each value into some transformed thing, array.map. And the type system does actually have a way of doing maps. You can say k in key of values. I'm just going to say blah for now. And actually, you know what? I'm going to, I'm starting to run out of space on my screen. So I'm going to collapse object schema and collapse my schema and this thing. But whoops, please let me know if you need me to expand one of them. I'm just toggling whether we see those lines because I'm running out of space. So where was I? Okay. Turn objects. Oh my God. I'm going to move that up so I don't have to see it. Okay. So turn object schema into object says for every k in the key of the values, I'm going to rename this to key actually. I hate single letter generics. It's always annoyed me. Incomprehensible. I'm going to say k in key values. The result is blah. And then I'm going to use this. Turn object schema into objects values. So now when oh man, I'm really running out of space here. I'm going to move this up. Face object schema. Now when I look at my schema, okay, we haven't gotten the right values, but we did successfully proof of concept that we can take some object and transform or map all of the key and value pairs into a different, well, same key, but different value pair. So my schema is now, instead of age, some number schema, it's blah. I'm going to pause there before we actually do the right thing with the values. Does that strike everyone as reasonable? Any questions?
You did say this was going to recurse, and I see how it's iterating. How are we recursing?
It's going to recurse. It doesn't yet, but that's a great point.
Oh,
you can
okay.
See...
I almost
yeah,
stepped ahead of
you. You've already finished. Yeah, so let's do that recursion. Instead of blah, what we actually want is we want to take in, well, first of all, values of key is how you would access. Remember when I did the array bracket of the property like an hour ago? That's this thing. Values of key. So now we're actually back to having the exact same thing. So that would be like schema number, e.g. schema number, or schema union of some stuff. Well, we want to recurse. We want to say, well, like, infer on that. I swear to God, this better work. Oh, there it is. Kind of. Sort of. It, well, it got age number. but it almost got literal fruit.
Technically, wouldn't you need to do a ternary here to say, hey, if I'm extending, or if the value key infer produces a standard thing, do it. Otherwise, oh, actually, no, you should be doing that. Never mind.
The
It's
recursion is
already
down
there.
there.
Yeah, the recursion is there.
Now I'm confused as to what's going on here. I'm gonna say this is a union schema. True, just to differentiate them. I don't think that's gonna fix things. Oh man, what a bummer. And my notes don't actually have another recursion type thing in the array one. So what do you mean, Adam? Oh my God. See, that's how I know this workshop is going great, because you solved it. Congratulations. That was definitely a test and not me just forgetting I reverted something. Yes, you're absolutely right. Infer a value. That makes total sense. You just applied great debugging techniques, I presume, because previously it was the schemas, the union of the schemas themselves, but now it's the values. Oh, wow. Amazing. Thank you. Great call. Very nerve-wracking leading these. My message is too long. Please try sending multiple shorter messages. So I'm gonna have to. Well, I can't share this right now. Maybe I can. There was a tsplay.dev. There was a site that lets you shorten these links. So I'm gonna send that to you now. There we go. This is the result. So just to recap what we just did, we added one last case, z_object, which is an object where we wanted to map same keys, different values. Or for each of the values, instead of the original schema that was there, like let's say a number or a union, we wanted to recurse. And there's no special syntax for the recursion part in the type system. Same as how you would call a function recursively, or two functions or one calls the other. You call it with infer. You pass the same values of key into the inference. And voila. Thus, we have completely recreated a very limited subset of schema validation, such as what you see in Zod. Hooray. Questions or comments on this finished thing?
It's going to take me a while to learn to read TypeScript like this, but it all makes sense.
Cool. I would definitely encourage that as a behavior. Take a break after this. It's a lot of new stuff. Read through it. The TypeScript docs have mentions of most of this stuff. Anything that's not in the docs will be in the TypeScript release notes, which is a surprisingly good form of documentation. And then I would suggest on your own time, also try to do this from scratch. Put it on a second monitor or minimize or something, and then go through number, union and so on in order to see if you can do it without using the reference. Cool. I have nothing else planned other than to just stand here for the next 15 minutes or so and answer/discuss anything that gets asked or brought up. How can I be useful to you all?
Yeah, we won't be awkward and make you sit here in silence while people think of questions. So I turn to the rest of you and I say, if you got a question, let's speed this up a little bit. Just turn on your mic and ask Josh your question. If we don't hear from you in the next 30 seconds or so, we'll just move to wrap.
Oh, I'm so glad, Adam. Thank you.
I'll read Adam's comment for the recording because the chat doesn't always make it. This was awesome. I was literally just saying to someone, quote unquote, I wonder how Zod does that. And now I know. And JB followed up with, it is no longer magic.
Cool.
Yeah. Turn complete languages, man. Who would have thought TypeScript would be one?
Ridiculous. And it's our fault as a JavaScript community. If we didn't have such weird and wacky JavaScript to begin with, a lot of these features wouldn't exist. Although I will say I like that Zod has this kind of inference. I think I'd be happy only with that existing.
Absolutely. All right, going once, going twice. Oh, what about important stuff to know for TSConfig? No one ever talks about that.
I love
There's
it.
your question.
That's really deeply funny to me that you were about to close it off. And then one of the most excitingly deep and, lots of content questions gets asked. Nicely done, Dane. Comedic timing on point. Yeah, no, TSConfigs. A lot of stuff in there. For those who haven't played with them too much, if you want, you can play with the TSConfig in the playground. Dane gets you. There are a lot of things here. If you ever go to aka.ms/tsconfig or just typescript.org/tsconfig, everything is documented here. That's not an answer to your question because go read the docs is, well, not supremely useful when a lot of the docs have a line and a snippet. But I'll give the names of a few top level, like important ones. I'll pause, see if there are any y'all want to explore, and then I can go through them in order. For type checking, I'd say, where is it? I'll just find them. Strict, or specifically strict null checks. My God, where's the strict option? There we go. Strict, which turns on a family of flags that make TypeScript stricter in a really good way. That's a really big one for type checking. For modules, oh man, I see now that they really expanded this, and going through them in order is not what we want. For modules, the big ones are module resolution and module. So module says what your module system is. So it says nodes version of ESM or CommonJS. And module resolution is, oh my God, there's so many docs in these ones. Module resolution is given some import statement. How does TypeScript try to find a file matching that import? And then if you are using TypeScript to transpile, you don't have to. A lot of people use like Babel or SWC or ESBuild. The emit section of flags is a big one. Do you want to emit DTS files, declaration files? Do you want to emit source maps? Do you want to transpile loop syntax more succinctly or more technically accurately? So like anything under the emit section would be useful there, with the big one being no emits that just turns off emit altogether. So we talked about strict, module resolution, and no emit. I can actually like go through those, but are there any other ones y'all want to talk about?
I think those are great ones. I'll speak for myself. I spend way too much time on module and module resolution for me to care.
Yeah. I'll start with those then. So the problem is there are so many different permutations of how people do modules. To recap, in Node.js for years, we just used, just as in it was the only thing we used, basically, CommonJS, module CommonJS. CommonJS equals require. Here we go. That's what you see here. Ignore this defined property. You might do like exports.something equals something, or export module.exports.something equals something. And then you say like const whatever equals require something. The problem with CommonJS is twofold. One, it's vague. Two, it's synchronous. Vague because /constants could mean constants.js, constants/index.js. It could mean like, actually .cjs and .mjs. They're now explicit file extensions that switch a file to whatever module system you want. That's fixed in the ESM or ECMAScript modules thing, which is imports and exports. Import something from something, export something. Also, it's synchronous. Notice how it's not await require. It's like just some function that happens to be called require. But if you want to use top level await or TLA, like let's say you want an await in one of your files, well, CommonJS is synchronous, then you need async. It doesn't work. So we have this new ESM or ECMAScript modules system. However, TypeScript let you use imports and exports ESM style before ESM was formally supported in Node and standardized. So in a lot of TypeScript files, you see something like this where it's still vague. We don't know if it's constants/index or just constants.something. And then you have a million different bundlers. Babel, Webpack, SWC, Veets, all these other things, which have subtly nuanced different ways. Some of them support this, some of them don't, this vagueness. So depending on what your system is, whether you're strictly correctly using ESM, or if you're using, you know, something that abstracts that from you, like TSUP or whatever, Babel or Webpack, you want your module to reflect that, and you want your module resolution to reflect that. There's actually an entire deep dive on modules, actually two of them really. There's like historical, how it came to be, which I'll link right here. And there's here's what you want to use. If you're using Node, I recommend Node 16 or Node Next, because Node 16 is, and that's referring to the algorithm used in Node 16. It's not that you're specifically using that version of Node. So I recommend Node Next. If you're using a bundler, I recommend ES Next, or if you're using an older bundler, one of these things. So there's that. Then for module resolution, there we go. It's similar to that. You can use Node and Node Next. In fact, I think module resolution defaults to whatever your module is. But if you're using a bundler, instead of ES something, use bundler, which is, by the way, what a vague statement. Model the module resolution behavior common to most JavaScript bundles. It's just, this is how most bundlers do it. If you need something more specific, you can configure that separately. So like most web developers, especially on the front end, use module node next, module resolution node next, or module resolution bundler. So I'm going to stop there because modules, indeed, what a cluster. Any questions or comments on that? Cool. The nice thing about this is for most projects, you set it and you forget it. So you don't have to deeply do this for most TypeScript dev work. Strict is awesome for type checking. There are a bunch of flags in TypeScript. Here we go, type checking. Gonna just skim over them. The strict flag enables a bunch of them. So if you set strict true in your TSConfig, they're all enabled. The most important two of them, which I'll cover now, are strict null checks and no implicit any. Strict null checks is something that if you've never used a traditional like type language, like older versions of C# or Java, might be surprising. In those languages, you can just put null anywhere you want. Like if something is declared to be, let's say, type string, you can say that thing equals null, and that's okay. That's what we call the billion-dollar mistake. Because in a lot of like interviews, traditional dev interviews, you get dinged if you don't put if argument is null, throw new argument null exception for every argument in every function, because null gets everywhere. The type system doesn't treat null as its own type in a lot of type systems. They don't have union types. In TypeScript, with strict null checks on, which is actually not on by default for legacy support reasons, well, then null becomes its own type. And in fact, if we open the playground to strict null checks false, we see that even though logged in user is users.finds, which find, by the way, returns something or undefined, we try to log it, we get this. Let's say const logged in username equals Dustin. We try to run it. Oh, we get a crash. Cannot read properties undefined. But if we turn strict null checks to true, aha, now we get the red squiggly, the logged in user is properly undefined. +1, Jamie. I also can't imagine working without strict null types. I used to. I can't go back. And C# does actually have an option for this now. The big problem was we had to get union types to be popular. And then when you're in a language that compiles down to bytecode, it's a lot harder to get union types. Thank God
Also,
TypeScript and JavaScript is so loose and wacky. Sorry.
I was going to say, it's also interesting because other languages, null is really JavaScript's undefined, and that's a whole nother layer of wackiness.
Yeah. Really hate that we have two null and nil or whatever values. Yeah, so yeah. I like the name null and everything else about undefined, personally. +1 Dane. Keep undefined. Cool. The other one is no implicit any. Let's say you do function get length stuff, and then you console or let's just say log length, console.log stuff.length. When you have no implicit any off or false, this is fine. Dane, just looking at the chat, Jamie, and Adam in alphabetical order. This is fine. Now, TypeScript has no way of knowing what stuff is. It could look through every single place this function is called, but the point of TypeScript is to let you know if you've done it wrong. So if TypeScript is using your code as the reference for whether something is right, kind of defeats the purpose. So with the no implicit any compiler flag on, which again is off by default, but may eventually be turned on by default, and it gets turned on by strict, TypeScript will say, hey, it's implicitly the any type. You didn't explicitly say it is, but you didn't tell us what it is, and we can't infer it from its initial value or any type annotation. You gave us neither. So it's the equivalent of saying explicitly this. Now, fun fact, the way one would typically write this function is you could do like string or string, but if you also wanted it to be used with like length 1, 2, 3, something like that, then what you'd probably want to do is like stuff is any type that has length number, which despite the fact that you're using the object braces here, actually does allow string, because string is a type that has length number. Fun fact about that.
That's actually a neat shortcut, and I will be using that.
Yeah.
Well, I'm just looking at the clock. You got a 1 minute topic?
Ooh, yeah. Empty object type in TypeScript. Type of pipe function. Great. Absolutely not, Adam. I would need at least 4 minutes to do that. So I'm just going to plug TypeScript ESLint. We have a bunch of rules in TypeScript ESLint that help you with there we go. Help you with type safety. One of them is the classic ban types, which has, fun fact, constantly irritated the TypeScript team because we banned the empty object type, this thing. In our V8, we're splitting it down to several rules. I'm going to shout out no empty object type. Oh, sorry for the light mode switch. This is totally valid TypeScript right here. Like any non-nullish value is, which is an empty object, is string, because this it doesn't say any object. It says any type, anything that's not null or undefined, which includes like string and empty array. So just to show off again, this is fine. This is fine. Horrifying. So highly recommend using TypeScript ESLint with TypeScript, because we have a rule that will yell at you for doing silly things like, oops, wrong page, doing silly things like that. And we explain in the documentation why this is not allowed and what you might want as alternatives. Ta-da!
Amazing. Well, Josh, thank you so much for this deep dive into TypeScript and how we could use it to write maybe more bespoke solutions, maybe write our own libraries if we need to, and then how we can better consume, and actually a few tips and tricks, I think, for actually writing application code with it. Quick plug moment. Think like hot ones at the end. This camera, this camera, this camera. What's going on with you? Where can we find you? What's next for Josh?
I'm so tempted to do my Conan O'Brien impression now, because that was one of the greatest experiences. You can find me on joshgoldberg.com. That has links to my social media things. The biggest thing I'm working on right now is TypeScript ESLint. We have a beta of our V8, which makes it a lot easier to enable typed linting, which is like the most powerful, awesome way to find bugs and stuff in your code automatically. Also, I'm one of the 2 organizers of SquiggleConf, which is, despite the fun name, a very serious conference about excellent web dev tooling, things such as TypeScript and linting. We just finished our CFP. I need to update the website for that. And we're gonna start having bulk ticket options available very soon. So if you're in any way interested in becoming a more efficient web developer, or going to a conference held in Boston in a very beautiful part of the fall in an aquarium, then please reach out and let us know. We're happy to work with you.
Amazing. Well, thank you again, Josh. We really appreciate you joining us for this special edition of Trainings with This Dot, and we'll see everybody next time. Have a great rest of your day.
Cheers. Yeah, thanks for having me. This was awesome.
This program is presented by This.Labs, a framework-agnostic consulting firm helping enterprises realize their technical goals through staff augmentation, consulting, project management, on-demand subject experts, training, and other professional services. Find out more at This.Labs.com.